Now we're going to look at multiplication of matrices. The product AB of an M by N matrix A and an N by K matrix B is found as follows. One thing I need you to notice is that the inside dimensions, the N and the N, must match. So the numbers on the inside have to match. You multiply each element of the first row of A by the corresponding elements of the first column of B. This is why the inside numbers have to match. Everybody has to have someone to multiply. So you do the multiplication and then you turn right around and you sum up the end products. When you do that, that sum is the first row, first column element of AB. Likewise, the sum of the products found by multiplying the elements of the first row of A by the corresponding elements of the second column of B gives the first row, second column element. So I can tell you what row, or actually I can tell you what element I want, and that tells you what row and what column you have to multiply. And it's always row times column. That's another reason I use RC, row times column. Also, the resulting matrix AB, when you're all done with your multiplication and your summing, will have size MK, which happens to be the outside dimensions. So that's one thing I could ask. Is it possible to multiply these two matrices? And if so, what will my resulting matrix size be? So it's something I can do. So I need you to pause me just a second and put matrix ABC in your calculator. And as I go on, I'm going to find, or I want to find, matrix A times B. First thing you need to do when you have multiplication, or even when you have addition, size the matrix. So A is a 3 by 2, B is a 2 by 3. Inside numbers match, so that means I can do the multiplication. Outside numbers, that 3 and 3, is going to tell me what my answer is going to be. So if I multiply, remember row times column, so I'm going to do first row times first column. 3 times 4 gives me 12. Negative 4 times 5 gives me negative 20. Now I'm going to have to move this down so you'll see all the multiplication. So you just multiply 3 times 4, negative 4 times 5. First row, second column, 3 times negative 1 gives me negative 3. Negative 4 times 2 gives me negative 8. 3 times 6 is 18. Negative 4 times negative 8 gives me positive 32. So you try multiplying second row times first column, second column, and third column and fill out your matrix down here. Actually, it probably is already filled out. Just double check it. So 2 times 4 will give me 8. 0, zeros are great. 0 times 5 gives me a plus 0. 2 times negative 1 is negative 2. 0 times 2 is 0. 2 times 6 is 12. 0 times negative 8, negative 0. Or positive 0. Whichever way you want to do it. Third row, first column gives me third row, first column element. I should have a 4 minus 25. 1 times negative 1 is negative 1. Negative 5 times 2 is negative 10. 1 times 6 is 6. Negative 5 times negative 8 is positive 40. So you do the multiplication first, then you turn right around and you add or subtract these values. So first row, let's see, I should have negative 8, negative 11, and 50. Next row, 8, negative 2, and 12. Told you zeros are nice. Last row, negative 21, negative 11, plus 46. Not too bad. So now we've got some problems we're going to do. Find the following products. Notice it says if possible. First thing, dimension BA. Excuse me. Find the size of BA. And it has to be in that order. B is a 2 by 3. A is a 3 by 2. Inside numbers match. Outside numbers, my answer should be a 2 by 2 matrix. So let's get B and A together and go do your first row times first column. Let's see what you end up with. And while you're at it, go ahead and do first row times second column and see if you end up with the following. 4 times 3 is 12. Negative 1 times 2 is negative 2. 6 times 1 is 6. Row 1, column 2, negative 16, 0, minus 30. I go ahead and do all the multiplication, and then I turn around and do the addition. So why don't you do the second row, first column, and second row, second column, and see if you end up with the following. And when you add or combine all these values, you should end up with that. Well, let's try it in the calculator. I'm going to go get matrix B. I think I put these in. Then A. There it is. So I need you to try these other ones. Go and size A times C. We can do it. Inside numbers match. My answer should be a 3 by 2. We'll see that in a second. I didn't check this one. Outside value, it'd be a 2 by 2, which is what I did end up with. So let me get my A and C so I can see those. Go ahead and fill out this matrix similar to what I've got right here. Pause me while you do it. You should have ended up with this, which should then give you that. Try it via calculator. You do need to know how to do this by hand. Even though on the test I won't be able to see it, but there are some problems that you cannot do in your calculator. You'll find those. BC. Let's see if I can get, well, you can see yours. Let's see, B is a 2 by 3, C is a 2 by 2. Inside numbers do not match. You cannot multiply this. So inside dimensions do not match. Matrix multiplication is not possible. That's all you can say. Let's see what your calculator will say. There's B. There's C. Dimension mismatch, which is what we're saying right here. The dimensions do not match. They have to say it a little bit more concise. Well, let's see. C squared. Well, C is a square matrix up there, and C happens to be a 2 by 2. So a 2 by 2 times a 2 by 2, inside numbers match. My answer should end up being a 2 by 2. So let me get matrix C together. Go ahead and do your multiplication. Pause me so you can practice this. See if you ended up with this. And upon doing, did you end up with that? Alright, let's clear this. I want to see if I can do it either way. So second matrix, we do C times C, and that's what we got down there. Let's try C squared. Number 3, let me square it. So notice I can do it either way. Alright, you got some homework you have to do. And that's it for now. Thank you.